Hi there and welcome to Mr. Arnold's Maths. In this video we're going to look at similarity with area and volume. So we'll have a look at the effects of similarity on areas and volumes. And I've just got a couple of notes here to give you before we start doing some questions. And basically that the linear scale factor, the LSF, the linear scale factor is when we divide corresponding sides. The area scale factor is when we divide corresponding areas, and the volume scale factor is when we divide corresponding volumes. Now, all of this is assuming that both shapes are similar. And a couple of other things that are important. The area scale factor is going to be equal to the linear scale factor squared, and the volume scale factor is equal to the linear scale factor cubed. So using that information, we're going to answer some questions now, and hopefully by the end of the video you'll understand what it is you need to do to solve problems involving similarity with areas and volumes. Okay, so we're given some similar shapes here and we're asked to find the missing area. So looking at the first question here, we're given two corresponding sides and we're asked to work out the new area. Well, if I'm given corresponding sides, that means I can work out the linear scale factor. And the linear scale factor is always the big side divided by the small side. 4 divided by 12 is 3. So the linear scale factor is 3. And returning to our notes, the linear scale factor squared will give me the area scale factor. So if I do the linear scale factor squared, that equals the area scale factor. And the linear scale factor was 3. So 3 squared equals 9. So the area will be 9 times as big as it was. So the new area is going to be equal to 7, the old area, so 7 multiplied by the area scale factor, which is 9. And 9 sevens are 63. So our new area here is 63 centimeters squared. That's the first one done. Second one, we're given two corresponding sides again, and we're asked to work out a corresponding area. So let's have a look. The linear scale factor is going to be the big side divided by the small side. Now always remember they must be corresponding, they must be the same type of side. So it's 28 divided by 7, which is 4. So we know that the linear scale factor is 4, and just before, like we did before, the linear scale factor squared will give me the area scale factor, which will be 4 squared, which is 16. So I know the area scale factor is 16. Now we're asking for the new area. Well, this time, because we're going from a big area to a small area, so we're going backwards, we have to divide here. So the new area is going to be equal to the old area, 320, divided by the scale factor, which is 16. And 320 divided by 16 goes in 20 times. So the the new area is 20 centimeters squared. Last one of these type, we're given two corresponding sides again, so let's work out the linear scale factor. The linear scale factor is going to be equal to the big side divided by the small side. So 17.5 divided by 5, and that goes in 2.5 times. Now, just like before, the linear scale factor squared equals the area scale factor. And 2.5 squared, well, let's just get out the calculator for this. 2.5 squared gives me 6.25. So it's 6.25. So the area scale factor is 6.25. Again, this time we're going from a small shape to big shape. So when you go from small to big, you multiply. When you go from big to small, you divide. So the new area is going to be equal to the old area multiplied by the scale factor, which is 6.25. And 30 multiplied by 6.25, 30 multiplied by 6.25 gives us 187.5. So 187.5. that is the new area, 187.5. Okay, so that's involving looking for areas. Now let's see what happens if we have to work, we're given the areas and we need to work backwards to get the sides. So these questions here were given corresponding areas and we need to work out what the corresponding side was. So let's look at example 1. Well, the scale factor is always the big divided by small, but in this case we're doing areas, so it's the area scale factor we're working out. The area scale factor is always equal to the big side, or the big area divided by the small. So 160 divided by 10, which is 16. So I know the area scale factor is 16, and like before, remember the linear scale factor squared, let's do that up here. The linear scale factor squared equals the area scale factor. That means to get the linear scale factor, we need to take the square root of the area scale factor. So the square root of the area scale factor will be equal to the linear scale factor. So once we've worked out our area scale factor, we can say our linear scale factor is going to be equal to the square root of 16, which is 4. So the linear scale factor is 4. So the new side is going to be equal to the old side, because again we're going from small to big. We're going from a small shape to a big shape, so we're going to multiply. So it's 5 multiplied by 4, and 5 times 4 is 20. So our new side should be 20 centimeters long. And that's question 1 done. Let's have a look at the second example we have here. We've got 81 centimeters cubed and 81 centimeters squared and 9 centimeters squared. So to work out the area, again, because we're dealing with two areas, we're getting the area scale factor. So the area scale factor is the big area divided by the small area, which is going to give us 9 centimeter, or 9. The area scale factor is 9. And like we talked about before, the linear scale factor is equal to the square root of the area scale factor. So the square root of 9 is 3. That means the new side must be equal to. Now again, we have to notice here that we're going from a big shape to a small shape. When you go from a big shape to a small shape, you divide by the scale factor. So it's 9 divided by 3, which is 3. And that is the length of the new side. Final example for similarity on areas. Again, we're going to get the area scale factor because we're given two areas, so we're going to work out the area scale factor. And the area scale factor in this case will be 125. So again, always doing the big area divided by the small area. And that equals, so let me just get the calculator. 125 divided by 20 equals 6.25. So 6.25. Now that's my area scale factor. To get the linear scale factor, so working backwards, we take the square root of 6.25, and the square root of 6.25, so I'm taking the square root of 6.25 is 2.5. 2.5. So the linear scale factor is 2.5. We're going from a small shape to a big shape, so we're going to multiply. So the new side equals the old side, which is 3, multiplied by the linear scale factor, 2.5, and 3 multiplied by 2.5 is going to be 7.5. So it's 7.5 centimeters in length. Okay, let's move on to some volume questions. Alright, we're told these two cereal boxes are similar in shape, so it's a similarity problem, and it says the smaller one weighs 500 grams. We're asked to work out the weight of the larger box. Well, if you look closely, you can see that we're given two lengths. We're giving a length here and a length here. Okay, now you have to recognize that the length of this side is equal to the length of this side, so they're corresponding. So what we can say is we can work out the linear scale factor. The linear scale factor is going to be equal to the big side divided by the small side. 25, that should say. 25. So 40 divided by 25, get your calculator out if you like. 40 divided by 25 gives us 1.6. So the linear scale factor is 1.6. Now, if we just return to my notes, if I cube the linear scale factor, that gives me the volume scale factor. So if I cube the volume or the linear scale factor, I get the volume scale factor. So the volume scale factor is the linear scale factor cubed, which equals 1.6 to be cubed. So get your calculator out and do 1.6 cubed and you get 4.096. So we get 4.096. So that is the volume scale factor. Now it tells me that the smaller one weighs 500 grams. That means the bigger one, the new volume, when I say volume, it is in fact mass, but it's the same principle. The new volume is going to be equal to 500 multiplied by 4.096, and that's going to equal, so I'm going to multiply 4.096 times by 500, that equals 2048. So the new volume is going to be 2048. And that's it, that's the new weight, 2048 grams. So that's question one. Let's have a look at the second one. So this time we're given two cups and we're told that they're similar in shape, and since the larger one can hold 2.8 liters, and we're asked to work out how much the smaller one can hold. So here we were given a we were told about the small shape and we were asked to work out the big shape. Now we're told about the big one and we need to work out the small. So this is working slightly backwards. Okay, again, analysing both shapes, we can see that the height of this is 43 centimeters, the height of this is 21. So let's work out, we're given two corresponding lengths, so let's work out the linear scale factor. The linear scale factor is equal to the big, 43, divided by the small, which is 21. And 43 divided by 21 gives me, ooh, this number looks nasty, 2.04762. So I'm going to round this to 1, 2, 3, 4. Say I'm going to go round it to 5 decimal places just to begin with. Now, if you're doing it all in one go on the calculator, won't have this issue, but I want to make sure that I don't compound any mistakes. So I'm going to round 1, 2, 3, 4, 5 places. So it will be 2.04762. 2.04762. Now, again, just to reiterate, we're asked to round to the nearest whole number of milliliters, but I don't want to round to the nearest unit straight away, because then I will compound my mistake a little bit later and it can make my calculation wrong. So I'm going to round first of all to 5 decimal places and then we'll round appropriately later. Right, so that's the linear scale factor. So now I'm going to work out the volume scale factor by cubing the linear scale factor. So if I take the linear scale factor and I cube it, that will give me the volume scale factor. So if you cube your answer, you get 8.58514. So we get 8.58514. So that's our volume scale factor. Now we're told about the big shape. we're asked to work out the small shape, which means we're dividing. So the new volume is going to be equal to the old volume, which is 2.8, divided by the volume scale factor, which is 8.58514. 8.58514. So using your calculator, 2.8 divided by 8.58514, and we get 0.32615, which equals 0.32615. I'll just double check that. 3261145, should I say 145? It's 145. Now you have to remember that this was in litres, which means my answer is in litres, and we're asked to give it to the nearest number of whole millilitres. So to go from litres to millilitres, you've got to divide by 1000, because there's 1000 millilitres in a litre equals 1 litre. So I'm going to divide this by 1000. 1, 2, so your decimal place moves 3 places to the left, which means we get 326. 326 milliliters. And that is question 2 done. So, okay, so now we've got some shapes that are similar again, and it gives us the volume this time and one length, and we're asked to work out the other length, x, correct to 1 decimal place. So we're given 2 volumes, so we can work out the volume scale factor. The volume scale factor will be the big volume, 290 cubic centimeters, divided by 20 cubic centimeters. So we can work that out. The volume scale factor will be 290 divided by 20, which is 14.5. So we know the volume scale factor is 14.5. And if you remember from earlier, the linear scale factor cubed equals the volume scale factor. That means to get the linear scale factor, we need to take the cube root of the volume scale factor. So I need to take the cube root of 14.5. So the linear scale factor equals the cube root of the volume scale factor, which is going to be equal to the cube root of 14.5. So I need to take the cube root of 14.5. I need to take the cube root of 14.5, which is 2.44. I'm going to round to 2 decimal places here. 2.44. 2.44. The linear scale factor is 2.44. That means that x, right? X must be, I'm going from small to big, which means I'm going to multiply by the scale factor. So it's going to be 6.4 multiplied by 2.44. So multiplying by 6.4, we get 15.6 to 1 decimal place. So it equals 15.6 to 1 decimal place. So our new side is 15.6. Okay, next question. We're given 2 cans. One is 550 mils, the other is 350 mils, and we're given one side, we're asked to work out the other side. So again, we're going to work out the volume scale factor, because we're given 2 volumes. So do the volume scale factor is going to be the big volume, 550, divided by the small volume, 350. So 550 divided by 350 gives me 1.57. So I'm going to round to 2 decimal places for now. So it's 1.57. 1.57. That means the linear scale factor must be the cube root of the volume scale factor. So I need the cube root of 1.57. So I'm going to take the cube root of this. So the cube root of that is 1.16. So it's roughly around 1.16. 1.16. Now you might notice that I'm writing down these to two decimal places, but when I'm doing my calculations, I'm just leaving it as it is. That's to avoid me making a mistake at the end. If you can do it on your calculator in one go, it's brilliant because there's less likely of you compounding any mistakes by rounding. Anyway, we need to work out x, so let's go and work out x. And if you notice here, we have the big side, we're going to a small side, so I'm going to divide. So we're going from big to small. This time we're going to divide. So x is going to be 15.4 divided by 1.16 divided by the linear scale factor. So I'm going to do 15.4, and I'm dividing by 1.16, and we get 13 point to one decimal place, 13.3. I make it 13.3. So x is going to be 13.3 centimeters, and that is how you solve problems involving similarity with areas and volumes. I hope you enjoyed the video, hope you found it useful, and best of luck with your questions. I'll talk to you again sometime.